Okay, time for boringest home videos. What I want to do with this video is to just show you how to go about making your own set of linear arithmetic blocks or decipipe. Essentially what you need to do is to start off with a washer. Now I've picked one that's about 2 centimetres in diameter. What matters for the construction, of course, is how thick it is. If I get 10 of these washers, hopefully you'll just see a disembodied hand and probably my bit of fuzzy head. So 10 of these washers, and see how thick they are as a stack. So these washers are my thousandths. 10 of them together are going to make the length of my hundredths, and what I need to do then is to cut up some PVC pipe, also 2 centimetres in diameter, so that the length of the PVC pipe matches the length of or the height of the 10 washers there. These are going to be my hundredths, and again 10 of those, which I don't happen to have all of them down here, but 10 of those together will make my tenths. And once I've made my tenths, 10 of the tenths together, if I stack them end to end, etc, 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 will eventually make my whole. So from a construction point of view, you have to start with the thousandths and work your way up. Obviously, for introducing it to students, you start with the whole and talk about the fact that there are 10 pieces in the whole, and you really should do it, so don't just skip like I was attempting to skip a minute ago. Really do show 9 and 10, so that the idea of tenths is really reinforced there. Now the nice thing about these materials is that they allow you to make some comparisons among decimals. So for example, and I can use the stick here to just help keep things lined up. So if I take something like 3/10 and 4/100ths, 1, 2, 3, 4, and 2/1000ths, then what I'm representing here is 0.342, 3/100ths, 3/10ths, 4/100ths, 2/1000ths, so 3.42, and I can easily make a comparison between 0.342 and something like 0.4, for example, if I get those ends lined up. And hopefully students will be convinced that the 0.4 is bigger than the 3/10ths and the 4/100ths and the 2/1000ths, and readily see that the 4/100ths really are too small to match up with one of the whole tenths. Obviously, one of the ideas is that when you've got 10 of something, you make the next size up object, and in fact that becomes important for sort of illustrating addition. So for example, if I want to show, let's do something like, what have we got here? Let's make it interesting, so a little bit of regrouping takes place. And in fact, for addition and subtraction, it doesn't matter too much whether you actually have them laid out lengthwise. You can safely really just make a sort of stack, if you like. So here's what we've got: 1, 2, 3, 4, 5, 6, 7, 8. So 8/10ths and 5/100ths. And here I've got my 3/10ths, 4/100ths. Oh, let's make a few extra hundredths on this one. Let's make it just so we've got a bit more fun. Okay. Okay. So we've got 0.89 added to 0.342, and when we put all these pieces together, it should be possible to see that with a bit of regrouping or renaming, if you like, 10 of these tenths, namely that many of them, can all get renamed as a whole. And when we put our, as I say, it doesn't really matter if things don't get lined up, when we put all our hundredths together, we actually had 9/100ths plus 4/100ths, so that's going to actually end up making 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course 10 of these guys can get exchanged for one of the tenths. So 10 of the hundredths is replaced by one of the tenths. And then we have 1.232 at the end. In terms of the cost of making such a kit, there's about $20 worth of materials there for buying, actually probably slightly less, for buying 2 really long lengths of PVC pipe and a stack of 30 washers. The extra thing that's useful is this guy, because he does really nasty things to pieces of PVC pipe. So it's just a matter of ratcheting him into position and getting the pipe into position and dislocating his shoulder and going like, which is much quicker than sawing it. There you go. Hopefully that explains a little bit about LAB and making your own stuff and how to model addition if you need to.